New kind of rationalizing now. We've got a denominator and it's got roots in it, so of course some rationalizing is called for. But we have two roots now, two separate terms, each with a root in them. And there is a way to counter this as well, but it requires something called a conjugate. Now, a quick word about those before we go on. Anytime you have a binomial, the conjugate is the exact same two terms, only with the sign in the middle switched. So if you have a plus b, the conjugate is a minus b. If you have x squared plus 8, the conjugate is x squared minus 8. You change nothing except that middle sign. If your original term, or sorry, your original binomial was minus x cubed plus 27, then the conjugate is minus x cubed minus 27. And it works the other way as well. If you have something like a minus 6, the conjugate is a plus 6. So that's conjugates. In this case, if we are to rationalize this denominator, we're going to multiply top and bottom by its conjugate, which is 6 root 5 plus 5 root 2. All right, change nothing except that middle sign. And I have to multiply by the exact same thing upstairs. So this is going to make a little bit of a shambles of our numerator, I must admit. But the denominator will get much better. That's what we're doing this for. So if we multiply these out, we get, I'll do the upstairs first, the bad news. 4 times 6 is 24. Root 3 times root 5 is root 15. Next term, 4 times 5 is 20. Root 3 times root 2 is root 6. And now the good news. Downstairs, we get 6 times 6 is 36. Root 5 times root 5 is root 25. I'm foiling here, of course. Outside, 6 times 5 is 30. Root 5 times 2 is 10. Inside, minus 5 times 6 is minus 30. Root 2 times 5 is 10. And last, minus 5 times 5 is minus 25. Root 2 times 2 is 4. Okay, can we clean any of this up? Please let us be able to clean this up. 24 root 15. Root 15 does not have any good perfect squares hiding in it, so we can't do anything to simplify that for now. Same with root 6. That isn't divisible by root 4, and all the other perfect squares are too big. So that we will have to live with. But downstairs we get some good news. 30 root 10 minus 30 root 10 cancels out. Gone. So we're down to 36 root, hey, I know what that is. That's 36 times 5. And then we have minus 25 times, hey, I know what that one is too. 25 times root 4 is the same as 25 times 2. So this is going to clean up to 24 root 15 plus 20 root 6 over 180 minus 50, which is, we're just reducing fractions now, and I'm going to run out of space if I start way over there. 24 root 15 plus 20 root 6 over 130. Can we do anything more with that? 24 and 20 and 130 are all even, so we could divide everything by 2 at the very least. 24 divided by 2, 20 divided by 2, and 130 divided by 2 leaves us there. And that's as far as we can clean it up. So numerator got a little messed up, but the denominator improved dramatically. This, where the outside and inside terms cancel, this will happen every time. That's part of the magic of a conjugate. A conjugate sets this up so that it will occur. These middle terms will cancel out. This will always be a perfect square, and this will always be a perfect square. So the conjugate guarantees that when you are done, your denominator will be a rational value. And that's what we wanted. That's what it delivered.